In this lesson, I'm going to go over how to solve equations that involve more than one or two steps. These equations can still just contain one variable, or you might see two variables being either on the same side or on opposite sides of the equal sign. So let's just take a look. Again, remember, in order to solve, our goal is to isolate the variable using inverse operations. But we may have some steps, a couple steps to take care of before we get into the opposite operation part of solving our equations. So for example 1, let's say we have 3x plus 5 minus 2x equals 8. So if you notice, we have more than one variable term, and they're both on the same side. So what we'd like to do is simplify both sides of the equation before we proceed any further. So right now I can combine 3x minus a 2x. You could think of this as we could reorder these terms so that we could see them next to each other. So one way I could think of this is saying 3x minus 2x plus 5 equals 8. Now that allows me to see the variable terms next to each other. These are like terms. I can combine them by saying 3x minus 2x. Well, that would just give me a 1x plus 5 is equal to 8. Now it's at this point, if you have viewed my previous lesson on 1 and 2 step equations, this is what we've kind of narrowed it down to or simplified it down to. So now my next step is just to undo this plus 5 by subtracting a 5 from each side. So now these 5s will cancel out, and I am left with x equals 3. And as I've done so in my previous lesson too, I always like to show that I am checking each solution. So again, if x is equal to 3, I'm going to have 3 times x, which is 3 times 3, plus 5, minus 2 times 3. I want to make sure that that turns out to equal 8. If it doesn't, that means I made a small mistake somewhere over here. So looking at this, I'm going to get a 9 plus 5. Negative 2 times 3 will give me a negative 6 or a minus 6. And that's going to equal 8. We're just going in order right here. 9 plus 5 will give me 14. And I'm still looking at this as 14 minus 6. I want to make sure that equals 8. So yes, on the left side here, 14 minus 6 does turn out to equal an 8. And I see that my left side is equal to the right side of this equation. A second example might need us to maybe distribute where we want to remove parentheses before we do anything else with our equation. So I might have something that looks like this. 2 times 3x minus 7 plus 4. Let's say that equals a 10. There's a couple ways to approach this. I always like to just make things simple just by removing the parentheses here. So this is where we need to use what we call the distributive property. I need to multiply everything inside the parentheses. This means I'm doubling this quantity. So I want to multiply everything inside by 2. As soon as I do that, it's going to turn back into what we had to do in the previous example here. So 2 times 3x will give me a 6x. This is really 2 times a negative 7, which will give me a negative 14 plus 4 is equal to 10. Now I still have some like terms over here. Even though I only have one variable term, I have these two numbers that it would be a lot easier if I would combine here. So again, I'm looking at this as a negative 14. I owe 14 and I have 4. So if you owe 14 and you have 4, you're going to owe 10 when you're done with this. So now this turns into 6x minus 10 equals 10. So next I want to take a look here. Now I want to undo this minus 10 here. So what I'm going to do is add 10. The opposite is to add 10 to each side. So as you've seen in the previous examples, this is where my 10s will cancel out. I will be left with a 6x equals a 20. Now all I have left to do is get rid of this 6 that's being multiplied by the x. I wish to divide both sides by 6. Now again, 20 doesn't divide nicely by 6, but I wish to put that in lowest terms. So I'm first going to write it as 20 over 6. But they each have a 2 in common, so I'm going to simplify this fraction, put it in lowest terms. If I divide the 20 by 2 and then the 6 by 2, I'm going to still get an equivalent fraction here, but this is going to give me 10 thirds. And we always like to see our fractions in lowest terms. Just makes it nicer, easier to work with here. So again, I'm going to show my check off to the side. I'm going to have, again, x is 10 thirds. I'm going to have 2 and then 3. Since it's going to be multiplied by the 10 thirds, I'm going to write it as 3 over 1. This goes back to that lesson that I made over real numbers. Rational numbers are any number that can be written as a fraction. So 3 I could turn into 3 over 1, and it's a fraction. Any number over 1 can be written that way. And then I want to subtract 7 plus 4, see if that equals 10. So again, when I multiply fractions together, this is going to give me 2, and then I could look at this 2 ways. This time I'm going to actually do this a little simpler. These 3's, I did it this way, these 3's will actually divide out, leaving me with a 1 here. So now if I multiply straight across, that's just going to give me a 10 over 1, which is just 10, minus 7 plus 4 equals 10. Now if I follow order of operations, I'm going to subtract what's inside here first. So this is going to give me a 2 times 10 minus 7 will give me 3. And I hope you can see now that we are going to get a 10 in the end here. So 2 times 3 will give me 6. And when I add 6 plus 4, I will get 10 on the left side, which matches the 10 on the right side. So our first 2 examples here dealt with simplifying, having to simplify one or both sides of our equations before we started on inverse operations. Now let's take a look at an example where we have variables on opposite sides of our equal sign. So if I took maybe 7x plus 3 equals, let me do 4, let's do minus 5x. All right, so what I'd like to take a look at here are the variables. I always like to look at those first. I'd like to get all my variable terms to one side. I'm going to do this. If you notice, I have a minus 5x here. So what I'd like to start off with is adding 5x to each side. So what I'm going to do is just write that I'm adding a 5x to the left side as well as to the right side. So now what's going to happen here, these 5x's cancel out. Over here, I can now add the 7x with the 5x. So that will give me a 12x plus 3 will equal a 4. Now if we take a look at this, I have 12x plus 3 that I'd like to get rid of the plus 3. I want to subtract that. Show that I am subtracting 3 from each side. Again, these 3's will cancel out. I am left with 12x equals a 1. After that, I have 12 times x, so I'd like to divide both sides by 12. And as I mentioned before, a lot of these problems don't work out too nice. So I'm just left with a fraction here of 1/12. So this is where it's really important to want to show this check. So over here now, if x is equal to 1/12, I'm going to take that 7 again, put it over 1. Times 1/12 plus 3. I want to make sure that that's going to turn out to be the same as 4 minus 5 over 1 times 1/12. So this will give me 7/12 plus 3 equals 4 minus 5/12. So now, since I have fractions involved, I'm going to go ahead and write everything with common denominators. So I'm going to look at this as putting a 3 over 1 and a 4 over 1. So I'm going to have 7/12 plus, I need to turn this into an equivalent fraction of saying something over 12. So what I'm really doing here is I'm multiplying the 1 by 12 and then the 3 by 12. So I get 36/12, getting common denominators. The same thing over here, I'm going to have something over 12 minus 5/12. So I'm going to take a look at here. If I multiply each by 12, this will now give me 48 over 12. Combining these now, 7 plus 36 will give me 43 over 12. 48 minus 4, 48/12 minus 5/12 will give me 43 over 12. And this is where it really takes shape, because we don't just have a single number that we could see right away. I have no idea what these two sides are going to come out to be until I substitute in that solution that I got. So because I got the same number on each side, I know that that is correct. And let's just try one more. Let's say we have 5x plus 8. Let's say 6x minus 12. All right, I have a few ways to get started. As I mentioned in the last one, I would like to start with the variables. Now in this case, I have a choice. I could bring the 5x over to the right side or vice versa. I always like to start with whatever's smaller. So in this case, I'm going to start with the 5x. I'm going to start by subtracting that from each side. Now I could have just written the 5x right next to the variable here, but I wanted to do it this way just to get some practice at looking that even if they're not right next to each other, these two are still going to cancel out. I'll have an 8 over here. 6x minus a 5x will just leave me with a 1x minus 12. So even though I have the variable on the right side, that's okay. My next step still will be to get rid of this minus 12. And I want to do that by showing that I'm going to add 12 to each side. So again, these 12s are going to cancel out on the right side. This time I'm just left with x is equal to 8 plus 12 will give me a 20, or I could flip that around to say x equals 20. Again, let me check this real quick. When x is 20, I'm going to have 5 times 20 plus 8 equals 6 times 20 minus 12. 5 times 20 is 100 plus 8. 6 times 20 is 120 minus 12. This will give me 108. And 120 minus 12 will also give me 108. So I ended up with an equivalent statement here, and identity is what we really call that, just by looking at the solution and checking it. Now, one other type of equation I wanted to kind of look at here is, let's say we are solving and we encounter something that has a 0. So let's say I have maybe 5x minus 3 equals 4x minus 3. We get to this step here, or this is what we're given. Again, I want to start with the variables. I want to go ahead and subtract 4x from each side this time. So I'm going to have 5x minus 3 minus 4x equals 4x minus 3 minus 4x. So again, these 4x's will cancel out. Over here on the left side of 5x minus 4x will leave me with an x and x minus 3. And over here I'll be left with a negative 3. My next step is to add 3 to each side. So I'm going to have x minus 3 plus 3 equals negative 3 plus 3. So this is an interesting case here where the negative 3 plus 3 will cancel from this side and also from this side. But when things cancel, and I say it that way because they're going to equal a 0. So over here, I still have this x to write. But over on the right side, it's just going to give me a 0. We never want to leave it blank or let that confuse you there. When things cancel, we get a 0. When things divide out, it's a 1. But let's check this real quick. So we will have 5 times 0 minus 3 equals 4 times 0 minus 3. 5 times 0 will just give me a 0 minus 3. 4 times 0, also a 0 minus 3, which leaves me with a negative 3 and a negative 3 on each side. And just a little extension with that. Let's say we're in the process of solving and we get a step that looks like this. 2x is equal to 0. Again, we want to divide by 2 on each side. So these 2's divide out, leaving me with a 1x. And 0 divided by 2 will just give me 0. So if we ever encounter this step, so let's say we had a 2 in front of this x here, we would have to divide it. So 0 divided by anything will just turn out to be 0. So I hope this lesson helped. As always, email me at help@thealgebratutor.com if you have any further questions or would like to request your own video.